1.5.1 Microprocessor specifications. Microprocessors are classified on the basis of different features which include chip type, word size, memory size, clock speed, etc. These features are briefly explained below. A. Word size. Word size is the maximum number of bits that a microprocessor can process at a time. Earlier, a word was of 8 bytes, as it was the maximum limit at that time. At present, the minimum word size is 16 bits and maximum word size is 64 bits. B. Memory size. Depending upon the word size, the size of RAM varies. Initially, RAM was very small, 4 MB, due to 4 by 8 bits word size. As word size increased to 64 bits, it has become feasible to use RAM of size up to 16 exabytes EB. C. Clock speed. Computers have an internal clock that generates plus as signals at a regular interval of time. Clock speed simply mean the number of pulses generated per second by the clock inside a computer. The clock speed indicates the speed at which the computer can execute instructions. Earlier it was measured in Hz and kilohertz, but with the advancement in technology and chip density, it is now measured in gigahertz, that is billions of pulses per second. D. Cores. Core is a basic computation unit of the CPU. Earlier processors had only one computation unit, thereby capable of performing only one task at a time. With the advent of multi-core processor, it has become possible for the computer to execute multiple tasks, thereby in increasing the system's performance. CPU with 2, 4 and 8 cores is called dual core, uh, quad core and octa core processor respectively. Activity 1.1. The maximum memory size of microprocessors of different generations are given at table 1.2. Represent each of the memory size in terms of power of 2. Activity 1.2. Find out the clock speed of the microprocessor of your computer and compare with that of your peers. 1.5.2 Microcontrollers. The microcontrollers is a small computing device which has a CPU, a fixed amount of RAM, ROM and other peripherals, all embedded on a single chip, as compared to microprocessor that has only a CPU on the chip. The structure of a microcontroller is shown in figure 1.9. Keyboard, mouse, washing machine, digital camera, pen drive, remote controller, microwave are few examples of microcontrollers, as there are designed for specific tasks only. Hence their size as well as cost is reduced. Because of the very small size of microcontroller, it is embedded in another device or system to perform a specific functionality. For example, the microcontroller in a fully automatic washing machine is used to control the washing cycle without any human intervention. The cycle starts with the filling of water, after which the clothes are soaked and washed. Thereafter, the water is drained and the clothes are spin dry. The simple use of microcontroller controller has permitted rep- repeti- repetitive execution of tedious tasks automatically without any human intervention, thereby saving precious time. Figure 1.9 Structure of microcontroller. 1.6 Data and information. A computer is primarily for processing data. A computer system considers everything as data, be it instruction, pictures, song, videos, documents, etc. Data can also be raw and unorganized facts that are processed to get meaningful information. So, understanding the concept of data along with its different types of crucial to understand the overall functioning of computer. Sometimes people use the term data, information and knowledge interchangeably with which is incorrect. 1.6.1 Data and its type. A computer system has many input devices which provide it with raw data in the form of facts, concept, instruction, etc. Internally, everything is stored in binary form 0 and 1, but externally, data can be input to a computer in the text form consisting of English alphabets A to Z, small a to Z, numerals 0 to 9, and special symbols like at the rate, hashtag, etc. Data can be input in other languages too, or it can be read from the files. The input data may be from different sources, hence it may be in different formats. For example, an image is a collection of red, green, blue RGB pixels. A video is made up of frames, and a receipt is made of numeric and non-numeric characters. Primarily, there are three types of data. A. Structured data. Data which follows a strict record structure and is easy to comprehend is called structured data. Such data with pre-specified tabular format may be stored in a data file to access in the future. Table 1.3 shows structured data related to monthly attendance of students maintained by the school. It is clear that such data is organized in row or column format and is easily understandable. Structured data may be sorted in, in ascending or descending order. In the example, attendance data is sorted in increasing order on the column month. Other examples of structured data include sale transaction transactions, online railway ticket bookings, ATM transaction, etc. Table 1.3 Structured data monthly attendance record of student. B. Unstructured data. 1. Data which are not organized in a predefined record format is called unstructured data. Example include audio and video files, graphics, text documents, social media posts, satellite image, etc. Figure 1.10 shows a report card with monthly attendance record details sent to parents. Such data are unstructured as they consist of textual contents as well as graphics which do not follow a specific format. Think and reflect. Can you give some more example of unstructured data? Figure 1.10 Unstructured data monthly attendance record. C. Semi structured data. Data which have no well-defined structure but maintains internal tags or marking it to separate data elements are called semi-structured data. Examples include email, document, HTML page, comma, separated values, CSV file, etc. Figure 1.111 shows an example of semi-structured data containing students' monthly month-wise attendance detail. In this example, there is no specific format for each attendance record. Here, each data value is preceded by a tag name, month, class, attendance. For the interpretation of the data value while processing. 1.6.2 Data capturing, storage, and retrieval. To process data, we need to first input or capture the data. This is followed by its storage in a file or a database so that it can be used in the future. Whenever data is to be processed, it is first retrieved from the file or database so that we can perform further actions on it. Activity 1.3 Visit some of the places like bank, automobile showrooms, shopping malls, tahsil office, etc. and find out 2 to 3 names of tools or instruments used to capture data in digital format. A. Data capturing. It involves the processes of gathering data from different sources in the digital form. This capturing may vary from simple instruments like keyboard, barcode readers used at shopping outlets. Figure 1.12 Comments or posts over social media, remote sensors on an Earth orbiting satellite, etc. Sometimes heterogeneity among data sources makes data capturing a complex task. Figure 1.12 Capturing data using barcode reader. B. Data storage. It is the process of storing the captured data for processing later. Nowadays, data is being processed at a very high rate and therefore data storage has become a challenging task. However, the decrease in the cost of digital storage device has helped in simplifying this task. There are numerous digital storage devices available in the market like as shown in figure 1.7. Data keeps on increasing with time, hence the storage devices also required to be upgraded periodically. In large organization, computers with large and fast storage called servers are deployed to store vast amount of data. Such dedicated computers helps in processing data effectively. However, the cost, both hardware and software, of setting up a data server as well as its maintenance is high, especially for small organizations and startups. C. Data retrieval. 1. It involves fetching data from the storage devices for its processing as per the user requirement. As databases grow, the challenges involved in search and retrieval of the data in acceptable time also increases. Minimizing data access time is crucial for faster data processing. 1.6.3 Data deletion and recovery. On One of the biggest threats associated with digital data is its del- deletion. The, the storage devices can malfunction or crash down, resulting in the deletion of data stored. Users can accidentally erase data from storage devices, or a hacker or malware can delete the digital data intentionally. Deleting digitally stored data means changing the detail of data at bit level, which can be very time consuming. Therefore, when any data is simply deleted, its address entry is marked as free, and that much space is shown as empty to the user without actually deleting the data. In case data gets deleted accidentally or corrupted, there arises a need to recover the data. Recover of data is possible only if contents or memory space marked as deleted have not been overwritten by some other data. Data recovery is the process of retrieving deleted or corrupted or lost data from secondary storage devices. There are usually two security concerns associated with data. One is its deletion by some unauthorized person or software. This concern can be avoided by limiting access to the computer system and using passwords for user accounts and files. However, possible. There is also an option of encrypting files to protect them from unwanted modifications. Activity 1.4 explore possible ways of recovering deleted data or data from a corrupted device. The other concern is related to unwanted recovery of data by unauthorized user or software. Many a times we discard our old, broken, or malfunctioning storage devices without taking care to delete data. We assume that the contents of deleted files are permanently removed. However, if these storage devices falls into the hands of mischief mongers, they can easily recover data from such devices. This poses a threat to data confident, confidentiality. This concern can be ma- mitigated by using proper tools to delete or shred data before disposing of any old or faulty storage device. Activity 1.5 create a test file and then delete it using shift delete from the keyboard. Now recover the file using the method you have explored in activity 1.4. 1.7 Software. Till now we have studied about the physical component of the hardware of the computer system, but the hardware is no use on its own. Hardware needs to be operated by a set of instructions. These sets of instructions are referred to as software. It is that component of a computer system which we cannot touch or view physically. It comprises the instructions and data to be processed using the computer hardware. The computer software and hardware complete any task together. The software comprises a set of instructions which, on execution, deliver the desired outcome. In, in other words, each software is written for some computational purpose. Some example of software includes operating system like Ubuntu or Windows 7 or 10. Word processing tools like LibreOffice or Microsoft Word, video player like VLC player, photo editors like GIMP and Lib- LibreOffice Draw. A document or image stored on the hard disk or pen drive is referred to as soft copy. Once printed, the document or an image is called a hard copy. 1.7.1 Need of software. The sole purpose of a software is to make the computer hardware useful and operational. A software knows how to make different hardware components of a computer work and communicate with each other as well as with the end user. We cannot instruct the hardware of a computer directly. Software acts as an interface between human user and the hardware. Depending on the mode of interaction with hardware and function to be performed, the software can be broadly classified into three categories, with 1 uh, system software, 2 programming tools, and 3 application software. Hardware refers to the physical components of the computer system which can be seen and touched. For example, RAM, keyboard, printer, monitor, CPU, etc. On the other hand, software is the set of instructions and data that make hardware function to complete the desired task. 1.7.2 System software. The software that provides the basic functionality to operate a computer by interacting directly with its constituent hardware is termed as system software. A system software known ho- knows how to operate and use different hardware components of a computer. It provides services directly to the end user or to some other software. Example of system software include operating systems, system utilities, device, drivers, etc. A operating system. As the name implies, the operating system is a system software that operates the computer. An operating system is the most basic system software without which other software cannot work. The operating system manages other application programs and provides access and security to users of the system. Some of the popular operating systems are Windows, Linux, Macintosh, Ubuntu, Fedora, Android, iOS, etc. B. System utilities. Software used for maintenance and configuration of the computer system is called system utility. Some system utilities are shipped with operating system, for example disk defragmentation tool, for formatting utility, system restore utility, etc. Another set of utilities are those which are not shipped with the operating system but are required to improve the performance of the system. For example, antivirus software, disk cleaner tool, disk compression software, etc. C. Device drivers. As the name signifies, the purpose of a device driver is to ensure proper functioning of a particular device. When it comes to the overall working of a computer system, the operating system does the work. But every day, new devices and components are being added to a computer system. It is not possible for the operating system alone to operate all of the existing and new devices, where each device has drivers characteristics, the responsibilities for overall control, operations, and management of a particular device at the hardware level is delegated to its device driver. Activity 1.6. Ask your teacher to help you locate any two device drivers installed on your computer. The device driver acts as an interface between the device and the operating system. It provides required services by hiding the details of operations performed at the hardware level of the device. Just like a language translator, a device driver acts as a mediator between the operating system and the attached device. The categorization of software is shown in Figure 1.13. Figure 1.13. Categorization of software. User interface, application software, programming tool, system utilities, operating system, device drivers, hardware. 1.7.3. Programming tools. In Word, in order to get some work done by the computer, we need to give instructions which are applied on the input data to get the desired outcome. Computer language are developed for writing these instructions. It is important to understand here the computers and humans understand completely different languages. While humans are able to write programs in high level language, computer understand machine language. There is a continuous need for conversation from the high level to machine level language, for which translators are needed. Also, to write the instruction, code editors, example idle in Python, are needed. We will briefly describe here the programming language translators, and program development tools. A. Classification of programming languages. It is very difficult for a human being to write instruction in the form of 1 and zeros. So, different type of computer programming language are developed to simplify the coding. Two major categories of computer programming languages are low level languages and high level languages. Low level languages are machine dependent languages and includes machine language and assembly language. Machine language uses one and zeros to write instructions which are directly understood and executed by the computer. But writing a code in machine language is difficult as one has to remember all operation codes and machine addresses. Also, finding errors in the code written in machine language is difficult. To simplify the writing of code, assembly language was developed that allowed usage of English like words and symbols instead of ones and zeros. But one major drawback of writing a code in this language is that the code is computer specific. That is, the code written from zero type of CPU cannot be used for another type of CPU. High level languages are machine independent and are simpler to write code into. Instructions are using English like sentences, and each high level language follows a set of rules similar to natural languages. However, these languages are not directly understood by the computer. Hence, translators are needed to translate high level language codes into machine language. Example of high level language include C++, Java, Python, etc. B. Language translators. As the computer can understand only machine language, a translator is needed to convert program written in assembly or high level language to machine language. The program code written in assembly or high level language is called source code. The source code is converted by a translator into the machine understandable, understandable, understandable form called object machine code as depicted in figure 1.14. Code in high level language source code to language translator to code in machine language object code. Figure 1.14 translator to convert source code into object code. As we have different types of computer languages, different translators are needed to convert the source code to machine code. The three types of translator used in computing systems are assembler, compiler, and interpreter. The translator used to convert the code written in assembly language to machine language is called assembler. Each assembler can understand a specific microprocessor instruction set only, and hence the machine code is not portable. We also need translators to convert codes written in high level language source code to machine understandable form machine code for execution by the computer. Compiler converts the source code into machine code. If the code follows all synthetic rules of the language, then it is executed by the computer. Once translated, the compiler is not needed. An interpreter translates one line at a time instead of the whole program at one go. Interpreter takes one line, convert it into executable code if the line is synthetically correct, and then it repeats these steps for all lines in the source code. Hence, interpreter is always needed whenever a source code is to be executed. See, program development tools. Whenever we decide to write a program, we need a text editor. An editor is a software that allows us to create a text file where we type instruction and store the file as the source code. Then an appropriate translator is used to get the object code for execution. In order to simplify the program development, there are software called Integrated Development Environment IDE, consisting of text editor, building tools, and debugger. A program can be typed, compiled, and debugged from the IDE directly. Besides Python, IDLE, NetBeans, Eclipse, Atom, Lazarus are few other examples of IDEs. Debuggers, as the name implies, is the software to detect and correct errors in the source code. 1.7.4 Application software. The system software provides the core functionality of the computer system. However, different user needs the computer system for different purpose depending upon their requirements. Hence, a new category of software is needed to cater the different requirement of the end users. This specific software that works on top of the system software is termed as application software. There are again two broad categories of application software: general purpose and customized application software. Activity 1.7. With the help of your teaching, install one application software in your computer. A. General purpose software. The application software developed for generic application to cater to a bigger audience in general are called general purpose software. Such ready-made application software can be used by end user as per their requirements. For example, spreadsheet tool Calc of LibreOffice can be used by any computer user to do calculation or to create account sheet. Adobe Photoshop, GIMP, Mozilla web browser, iTunes, etc. fall in the category of general purpose software. A computer system can work without application software, but it cannot work without system software. For example, we can use a computer even if no word processing software is installed, but if no operating system is installed, we cannot work on a computer. In other words, the use of computer is possible in the absence of application software. B. Customized software. These are custom or tailor-made application software that are developed to meet the requirements of specific organization or an individual. They are better suited to the needs of an individual or an organization, considering that they are designed as per special requirement. Some examples of user-defined software include websites, school management software, accounting software, etc. It is similar to buying a piece of cloth and getting a tailor-made garment with the fitting color and fabric of our choice. 1.7.5 Proprietary proprietary or free and open source software. The developers of some application software provide their source code as well as the software freely to the public, with an aim to develop and improve further with each other's help. Such software is known as free or open source software FOSS. For example, the source code of operating system Ubuntu is freely accessible for anyone with the required knowledge to improve or add new functionality. For example of FOSS include Python, FOSS include Python, LibreOffice, OpenOffice, Mozilla Firefox, etc. Sometimes softwares are freely available for use, but source code may not be available. Such software are called freeware. Examples of freewares are Skype, Adobe Reader, etc. when the software to be used has to be purchased from the vendor who has the copyright of the software, then it is a proprietary software. Example: the proprietary software include Microsoft Windows, Tally, Quickhill, etc. A software can be freeware or open source or proprietary software depending upon the terms and conditions of the person or group who has developed and realized that software. Activity 1.8: with the help of your teacher, install one free and open source application software on your computer. Think and reflect. When a computer is turned on, who brings the OS into RAM from the secondary storage? 1.8